battery. I forgot to plug it in. So, what'd you say, Cece?
What is that?
What? Oh, that was Teams. That's where I record. Yeah. Same thing we use when we did the online stuff. All right. So quickly, if you did not immediately know the answer to number 1, which a lot of you don't have this correct, you need to make sure you get this down. If you see anything next to each other and no math in between them, it's multiplication. 3x, remember we talked about this a lot, a number next to a variable, it's the same thing when you see the 2 next to the parentheses. So 3x is 3 times x, but 2 next to those parentheses means we're going to multiply 2 times whatever we would get in the parentheses if we could figure it out. Now we can't, kind of moving on to number 2, we can't do anything else with this 3x and that subtract 5. You can't combine them. There's no way, because I don't know what x is. If x is 1,000,000, that would make the answer in here much different than if x is 1. So I can't combine them and just say it's 8x or negative 8x or negative 2x or 2x or any of that. I just leave it like this. That's all I can do. And then if I wanted to, I could do the distributive property, if you remember that, where you say 2 times 3x and then 2 times negative 5. We're going to get into that more this week. Well, no, multiplication was the answer. But again, that wasn't the one I was talking about. Number 3 was the one you never got to. So,
Oh, no, I already wrote it down.
Number 2, you should have just copied down. I just went over what that means. You cannot add a term like here, x plus 1. I can't combine that. It's just, all I can do is leave it as x plus 1. I don't know what this number is, so how can I possibly combine it with the number 1? I don't know what that answer would be. So now let's spend some time on this one. Guaranteed, by the way, quiz question. I don't know if it'll be this week, but when we get into the more detailed word problem lesson, this is the first problem we'll do, and you will see that on the quiz. Write it out. So if I know what sum means now, which means what? What does sum mean? It means the answer technically to an addition problem, but yeah, addition. And then I know what consecutive means. What does consecutive mean? Savior. What's consecutive mean? Like in a row, like it wouldn't be the same number, so repeating is probably not the best word. Like it wouldn't be 150, 150, and 150. It wouldn't be repeating that way. It would be 150, 151, 152 in a row. The next one after the next one. So if I know those 2 definitions, now I just got to plug in a bunch of numbers. I could say, all right, well, as a very quick start, let me start with 100, 101, and 102. Because that's basically simple math. Makes my math pretty fast. It gives me a good starting point. It's not going to be that close to the answer, but it's fast, so I don't care. Pretty easy to add those 3 together. All right, 303 is pretty far away, right? I'm 200 something off. So I need to go way higher. Hopefully you realize I needed to guess higher as my first number. So I'm going to go way higher. Well, I'm going to make my math easy. So 200 again makes my math really easy, because then it's 201, 202. Well, and you can. That gives me 603. Now I'm too high. So I need to come back and say, okay, I need a number in between 100 and 200. But who am I going to call on Riley? Since Riley's on the phone. Where would you guess my next number? What's a good, if this was too low and this was too high, where would you start with your next guess to get 3 numbers? One what? I could start 120, but let me ask you this. Which one of these was closer, the 100 or the 200? So wouldn't I want to be a little closer to the 200 when I started? I love 170. Let's do 170. Now I could just split the difference. Let's say I didn't notice this was closer than this. I could just split the difference and say 150. But if you pay attention, you go, okay, well I know this was a closer guess, but I need to be lower. then you might say 170. Right? So let's add those up. 3, 1. All right, I did get a lot closer. Less than 20 away now. So what'd be another one? Who wants to do the next guess? Ashton.
175.
I like 175 a lot. And again, you'll notice they're always consecutive. 100, 101, 102. 200, 201, 202. 170, 171, 172. 175, 176, 177. They're always consecutive in a row. So now let's do the math on that. Wow, am I close now? It's close. Now, Jasmine, what do you want to go with next? 170 what? I'm going to just go 1. If I'm only 3 away, I'm just going to barely increase it. 177 wouldn't be bad. You could get a little too high, then you'd realize you'd have to go back lower. But just to kind of wrap it up so we can keep moving. If we do those 3 numbers, that's the 3 numbers. So that's one strategy for solving those types of problems. It's just like we said in the other ones, plug in numbers. Keep plugging in numbers and doing the math until you get the right answer. There are going to be some situations, though, where it asks you to create the equation, and it's not even worried about what the answer to it is. So that's really more the purpose of today. There's 2 things you need to get out of today. Kind of like your 2 first steps to creating an equation. So if we want to create so we have a word problem, right? Does anybody, are you still copying that, anybody? If we have a word problem, there is a first step I gave you that only maybe a couple people did. What's the first step when you're creating, not in solving, it has nothing to do with solving. What's the first step in creating an equation from a word problem? Lunch is over. You like rubber bands more than you like them? What's the first step? Look it up in your notes. Look up the icy airhead problem when we created the equation. You should have written down next to that problem what the first step is. I don't have them now, but I'm going to get you a folder so you can keep all your stuff in a folder, and that's what all of these folders that are in these things over here. It's just people that keep their notes right in here. That way it'll always be here for you. You'll always have them for a quiz. All right. I meant to bring some in. I totally forgot. But I'll get you one for today. This one here is just all right, this is going to be yours for now. If you want to trade it out with a blue or a red one, that's fine, but I'm going to write your name on this one. I owe somebody else didn't have one. I can't remember who it was. But, ooh, that writes really well. I need to drive. Bless you. All right, what's the first step? We said. Say it again. All right, somebody takes notes, thank goodness, and can find them later. All right, so what was that first step? Who heard it? Zoe, what was the first step?
Why are you picking on me?
Because you guys are having too much fun, I want to be involved. What's that first step? Oh, don't you laugh, because guess what I'm coming to do next? What's first step? Sandra, you're smiling, you're not laughing, but you're smiling. What's first step? Brent.
Just find out what variable.
Good. Somebody listen. Josh talks really quietly, so first step. We're going to add to this, but just for now, you can write both of these 2. It's technically creating equations from a word problem, which you should have written before. I'm not going to write from a word problem, because really the only time we create an equation is from a word problem. You two. Did you guys know each other before the beginning of this year? You never know. All right, step 1. You got to define. I'm going to use the word define. Define. All that means is what's the variable stand for? So define the variable. And you'll see, give yourself an example of this in a second when we do it. In the word problem that we did with the ices and the airheads, we didn't know how much one airhead was. So when we defined the variable, we said, whatever the variable was, x, whatever it was, x equals, or x stands for how much one airhead costs. So that's defining the variable. You're just saying, hey, what do I not know? And let me create a variable that stands for what I don't know. We're going to do that in a second. No, let's do it now. What's the variable in this? What do we not know? Are you talking about the problem, or are you telling me something about her? She didn't say she's having this stuff. She's coming in to do extra math. She's a former student. Who said it? Somebody said something. What'd you say? Well, I hate using the word constants because they're not a constant yet. So what do we not know? Because remember, a variable is the unknown. Like variable is what we don't know. A constant we know, like it doesn't change. So what do we not know in this? What are we trying to find? Yeah, we're trying to find the three numbers, right? Now here's one thing you can't do in this problem or in future problems. X, or the variable, yeah, we'll use X, that's fine. X, which is going to stand for something, can't stand for all three numbers. Because the numbers are going to be different, right? Right? They were all in a row. They were all different. X can't be different numbers. Whatever a variable is, it's always the same number behind it. Like when I did the Tootsie Roll example, every bag that was representing a variable had the same number of Tootsie Rolls in that bag. All variables, like X, if X we determine is, well, we kind of know what it is because we solved for it already. So let's say X is 176, which is one of the numbers. X is always 176, so it can't be 177 and 178. So what do we need to do? And I'll put that. So we'll say X is the first number that we don't know, first unknown number. So what do I need to do then? What do I need to do then? Because I can't make X all three numbers. What do you think, Ariana? What did you say? Oh, you didn't. I can't tell sometimes if you're saying something or not. You're so quiet. What can we do? What else do we not know? What's that? We don't know the second number. So what would we do? Would we write X equals the second number? Are they the same? Can we do that? Because they're not the same number. Can't do that if they're not the same number, right? So what would we do? Ooh, we're going to get to that later. Tokyo, help out.
Use it in variable.
Yeah, remember, if you change candies, you change variables. Same thing. If we're changing the unknown, then we need to change variables. So we just use a different variable. So along those same lines, I'll kind of finish the third one off for you. So we don't know those three numbers, the first one, the second one, and the third. Right? Yes, Mr. Gill. Thank you. I sometimes, so I have a little dog. I told you I have a little dog. So sometimes I like, do you know the movie Frozen?
Yeah.
Like, do you remember the movie Frozen and the guy with the moose? Moose?
Yeah.
Yes. You know how he like carries on a whole conversation and he talks and then he does the voice of the moose. I do that with my dog all the time. So sometimes it looks like I'm gonna have to do it with my students. So we now know the three variables. What's the math we're doing with those three variables? We said we were going to add them all together, right? So we got almost the whole equation created. Now there was another piece. So this is the second piece that you need to add into here. Hopefully you have room. What's the second thing I said to look for in a word problem? Like in the word problem itself, look for this because it's almost always going to be in there, and it's always, almost always easy to figure out where to put it. You have that icy and airheads thing still saved isn't right. Marked, I guess, is a better word. What? So you define the variable, and then the next thing. I said it was pretty easy to do. You're looking for some type of number we set in there. This number is a constant, but there's something else that I would call it. Because there could be a bunch of constants. This one's a specific constant. What do you think? Total. Write that down. Look for a total. Might not be one, but it's always a good idea to look. In the ICE airhead problem, the total was $5. It was Raymond. Raymond went in, bought a bunch of stuff, and the total, it even said total in the word problem. The total he spent was $5. So $5 was the total. Almost everything I've created in past quizzes, and I'm sure future quizzes, is going to have a total. Because it's just like the most realistic way to do a word problem. That's
And your total is your max that you want to go to.
yeah, because the total is going to be made up of everything else. Like you buy all this stuff, well then you're going to spend a total amount of money. Let's say you're saving money, well you're going to have a total amount saved. Like it's a very common real life situation. But is there a total in this? Because this isn't really a real life thing so much as a made up math problem. Is there a total in this one then?
531.
Yeah, there is. You betcha. I just told you almost everything I show you is going to have one, so you can bet there's one. That's a total. Where would we put a total typically in the equation? Yeah, it'd be after the equal sign all by itself. Could actually be on the left, although normally you'll see it on the right. But technically you could have put it on the left. There you go, that's your equation right there. All of the numbers added up will equal 531. Here's the trick. We can't solve that. We have 3 variables in one equation. That's not possible to solve because there's too many different numbers that those x, y's, and z's could be. I could have 100, 200, and then 231. I could have an infinite number of numbers. But yet we solve it. How are we able to solve it? Because I just told you we can't solve that, but we did solve it. We know we got the right 3 numbers. How are we able to solve it? What am I missing? How is my logic? I hate bad logic. I'm using bad logic right now. I'm missing something. What am I missing? Some classes I can't shut them off. Some classes. And then somewhere in between. You guys are actually kind of in between. What am I missing? What is super, super important? One word. Well, sort of. Yeah, what's important about that word? Consec. Let's think about it. Let's think about it. I want you to really think about it. Let's look at some consecutive numbers. Let's go with 100 because I think we use these. So there's some examples of consecutive numbers, and you could write a bajillion examples of consecutive numbers, and this will always be true. How do I get from the first number to the second number in those sequences? Every time. What am I doing to go from the first number to the second number? So what am I doing specifically to go from the first number to the second number?
Keeping that up constant.
Yeah, but I could do this with negative too. What do you do to go from 1 to 2?
You add.
Add what?
Add 1.
So what do I do to go from 17 to 18?
You add 1.
So what do I do to go from 100 to 101?
You add 1.
I'm adding 1 every single time, right? Doesn't matter what 3 consecutive numbers you have, you're adding 1 every time. How do I go from the first number to the third number every time?
You add 2.
I don't need 3 different variables. There's a relationship that is created by this word consecutive that says I don't really need to define them with a completely different variable. I can just take the first number which is x, and say, okay, well, the second number is always going to be x plus 1. And I can say the third number is always going to be x plus 2. Now I only have one variable. So I can come back over and change my equation. And,
Still recording?
it is recording. Well, actually, yeah, better be. There. So I can come over and I can say, all right, well, let me get rid of those different variables because I couldn't solve with those in there. And let me change it to be all one variable, but I'm just going to add in this plus 1 for the second number and the plus 2 for the third. Now I can solve that problem. I would combine like terms. So x and x are like terms. 1 and 2 are like terms. There. And then if you solve that out, you'll get the first number is 176. And then for the second number, you would add 1 to that. For the third number, you would add 2 to that, and that would give you the 3 numbers. All right, so we're going to do a lot more with word problems in a more full lesson, but I like to introduce it a couple of times quickly beforehand. What did you need to get out of that? 2 things.
I don't know how to make them.
Well, but how, like, in the process of making it, there's 2 things you should get out of it. No. What should you get out of that? 2 things, I said. This is part of making that.
Or am I way off?
Well, it would be helpful to look at the 2 things I have written right there.
Oh.
Yes, the 2 things are the 2 things that are still right there on the board that you should have written down. 1, you need to define the variable first. What do you not know? That's the first thing. And if you know everything, you wouldn't need an equation. So there's something you don't know, or that they're telling you to do. So define the variable, and then next look for a total to see if you can just kind of make a really easy ending number part of the equation. All right, so we're not done. Oh, I gotta put that up. There we go. So now I want you to go back, if you started that lesson somewhere about the rational, irrational stuff. We're going to wrap that up, although we'll probably finish it. I only finished it in 1 class so far, but we'll finish it here. So quick review of me and my ex-girlfriend. And I'm not talking behind her back. I would totally tell her that she's irrational. I have. So I'm not talking behind her back. And she would admit it. She's like, yes, I'm irrational. Just means emotional. Like, she knows she's emotional. So I'm very rational. I like things to make sense. She's a lot more emotional, so she doesn't always make sense to me. So irrational, we said, doesn't make sense. Rational makes sense. That was the general definition. So here's the way this applies to the lesson. Rational numbers are numbers you're pretty familiar with. You've seen rational numbers since you were in elementary school. Negative numbers are rational numbers. 0 is a rational number. Normal positive integers are rational numbers. Mixed numbers, like mixed fractions, are rational numbers. You've seen those since elementary school. Okay, regular fractions. Even a negative regular fraction. A decimal, you've seen decimals forever. Even a unique decimal, like something with that line over it, you've seen that. You should have seen that since certainly middle school, if not even elementary school. What does this mean, by the way? 0.3. What? That was right. I think you said the right word. Yeah, it's a repeating number. This is actually 0.33333, and it goes on forever. So we can't continue to write a 3 forever. So we just say, oh, well, I'll just put a line over it, and that line will represent that it goes on forever. All of these numbers can be written down in a decimal or really in a fraction form. Like this is 1/3, this is 1/8, and that's the true definition of a rational number. It can be written as a fraction. But I want you to think of rational as, hey, I've seen those numbers since elementary school and middle school. That's a rational number. Here are the numbers you haven't seen as much that are irrational. Pi, that's irrational. You don't see that a whole lot. And it's actually a number. It's so weird we use a symbol. We can't even write it as a number because it's so weird. It's 3.1415 and it goes on forever. It never repeats, never terminates, goes on forever. This number will also go on forever. That's the square root of 2. That is not a division symbol. You think that's a division symbol, you need to get that out of your head. If it's got this little piece here, that's a radical symbol, or in this case, a square root symbol. Those numbers never repeat, they never terminate, they go on forever. You can't write them down because they go on forever. So we have to use some kind of a symbol to help us write them down. Those are irrational numbers. So here's what you need to copy down. Hopefully that helps you understand a little bit. For a rational, so for all numbers, so write that down. If you have a rational number, I'm going to use emojis. That is a rational symbol. Could be any number that's a rational number. But again, just think rational. Mr. Gill is rational, that's his emoji. Plus, so literally the operation of addition. And then if you add something that's irrational to that, I am a fantastic artist. If you add an irrational number to that, you need to write all these down, by the way, because this part of the next quiz or whatever quiz they're on will be as simple as just looking it up in your notes. I'm not going to make you try to learn this piece of it like I will some other stuff. If you have a rational plus an irrational, that's always going to be an irrational answer. The answer, whatever number you get, will be an irrational number. So here's the way I want you to remember it when you don't have your notes, even if this is the only one that sticks in. Oh, wait, I did it wrong. Stop. God, I did it twice like that. I'm reading the one below. That goes for that one down there. I'll put the other one up and you can copy it. Hopefully you don't write in pen. That's why you don't write in pen. There. If you have rational plus rational, it's also rational. So here's the quick, and this actually is the one that you're going to use for almost everything. So this is your go-to. If you forget everything, I'm about to give you what you go to in this lesson. If you see it on the PSAT or the EOC next year. If I'm a rational person, and I like to make sense, and let's say Ashton is a very rational person, he likes to make sense. If we have an argument or a debate, even if we disagree, we're going to have like a good conversation about it because we're both rational. We're going to use facts. So our conversation is going to stay rational. It's not going to get all crazy and start talking about nonsense and yelling and screaming. Rational and rational is just going to stay rational. Again, we can disagree, but it's still going to be a nice, calm conversation where I explain why I believe what I believe and he explains what he believes. So rational plus rational stays rational. Now, if I argued with my girlfriend, however, ex-girlfriend, she would start going crazy and saying nonsense, and I'd start to get all fired up, and then